Okay, time for another review. Now this one is well, fairly new. This is actually a fairly new unit, or it's a very early unit anyway. So it's the SDM3065X, 6.5 digit multimeter, and this has been lent to me by Rob again from Tapaki Technologies. So I'll probably put a link in the description or something to his website or his email address, something like that. Okay, so this unit comes with various accessories such as power cord, as you would expect, a USB A to B cable for connection to a computer. It also has a rather nice set of silicon test leads. Got those shielded ends, like in us, these are the insulated ones. Quite nice points on those, quite sharp. And also has some clip leads as well, and some little bungs for these to stop deforming if you're not using them. Okay, so it's, you know, it's a standard test lead set, but they're quite nice. They feel reasonable quality. Okay. I'm not using these in this instance. What I'm doing. It also comes with the CD with the manual and software, and it also has a cal cert as well, so that's all there. This particular one didn't come with a quick start guide, which is unusual, but the quick start guide is actually on the CD, so it's not like you don't actually have it. It is there, just not in a printout form. So the manual and the software is on there as well. Okay, so that's all the accessories that go with that. Now I'm going to be doing some side-by-side comparisons with this meter with some of my own meters. So I've got a range of meters here, various different prices and ages. So I obviously got the 3065X sitting here, which is balanced quite well on my stack of meters. Alright, so I've got this one here. Now I'm going to back out a little bit. You'll see the meters I'm using. Okay, get the tripod back down. Right, it might be a little bit too close still, but here we go. So we have a HP 3478A, 5.5 digit meter. We have a Fluke A842A, another 5.5 digit meter. We have a Fluke 45, which is a 5 digit meter. Yeah, I suppose you can say it's 5, sort of 4.5 digits. I can't remember what the actual official spec is on that. And a Vici, which is a little Chinese one, which is 5 digits as well. Okay, or might be 4.5 digits even. I can't remember. So I'm going to be doing side-by-side comparisons of some tests on these. Unfortunately, the display on the HP is not very easy to see, so I'll probably have to read it out to you when I'm trying to do comparisons. But all the other ones you can see quite nicely. Yeah, all these meters here, when I picked these up, they're all working fine. So I've not repaired any of these meters, so they all should be as good as they ever were. These came with cowls on them, but expired cowls, right? So I think the Fluke 45 was the same. It also had an expired cowl on it, right? So my testing on these has been pretty good. The little Vici one, like this little Chinese thing, it actually works quite well. You know, it's a little budget meter, but it's actually fairly accurate considering the price it was and the feature set. So anyway, what I'm looking for is this one here. Okay, so I've got my test set up here. I've got the power supply running in the background, which isn't currently activated. I'm going to turn it on. As you can see, it runs on my bench lighting, which may be washing out the display a little bit. I might have to look at disabling that. Hold on. Let's kill that. There we go. Right. So here we are with a 0.99 volt, or so 990 millivolt, or thereabouts, out of the power supply. And you can see the various voltages that have been generated. So I've got 0.9911, 0.99112, you know, so it's like within, what's happening, millivolts. I don't know. I can't be bothered working it out. 0.9911 again, 0.9912, and 0.9908. So the Vici at this very low level is the least accurate. You can see they're basically all agreeing with each other. The Fluke has probably just got a rounding thing on it. It does seem to be sitting slightly higher on the Fluke 45. But again, now this one here's come up slightly, so that's actually agreeing with that one. So there's a bit of variation here. They haven't all been on for that long. They've only been on for about 15 to 20 minutes at this stage, so it's not actually been a long enough warm-up period yet. This has been on for about 2 hours, I think. This one here, the actual 3065. I've been playing around with a little bit, just trying to learn it a little bit. But so I haven't had much use time on this yet. I've only sort of played with it a little bit. I haven't actually used it much, so I'm going to be covering that more in the review. Once I've got more used to it, I'll be doing more bits like that. And so these have only been on for a short time, so there's going to be some warm-up period stuff going on there too. But initially, you can see that they're very close to agreeing with each other. They're very, very close indeed. So I'm going to leave all these to warm up for hours, and then we'll see how that settles down. And there's 1 meter which I should also include. This has to be the absolute standard, so for accuracy you have to rely on this meter here, because it's EEVBlog BM235, right? So if you're in any doubt of the accuracy of any of these other 5 meters, don't worry about that, just look at this one, right? Because this, Dave will know, Dave will tell you that's the best one. Out of all of them, that one. Yeah, okay. Anyway, so I've got this here as well. This is a comparison of a bench meter versus a modern multimeter. Okay, so I've had this meter from Dave for a few months now, and I've only just turned it on as well, so it's got obviously its own warm-up period too. But you can see that comparatively it's very, very close. It's 1 millivolt out compared to the other meters. No, yeah, a millivolt on that one as well. So it actually agrees with that one pretty much, but I think it's a slight rounding thing there. So on the very bottom end, it's out just a little bit, like 1 millivolt. I mean, that's not bad, is it, really? So we'll do comparisons with Dave's meter as well, and we'll see how we go. It's going to be interesting. Right, so these meters have been warming up for quite a while now. So, what time is it now? Oh, look at it, it's almost 11 o'clock at night. I started, was it about 5:30? I think I had these powered up, so they've been going for 5 hours, right? With the exception of this one, I turned this one off a little while. You might notice that now it's got a white light here. I got sick of not being able to see the display, so I pulled the thing apart, stuck some LEDs down the side. Yeah. Anyway, EEVBlog meter, it's powered up. I've only just powered up because obviously being battery powered, I don't sitting there draining the batteries out. So it's still pretty much, yeah. As you can see, there's some variation. What I've got this one currently doing, I've got it graphing it. So the power supply regulation, it's just, you can see all the meters are agreeing that it's fluctuating very slightly. So you can see here that on the graphing that it's actually doing that. So that's one of the nice features of the meter, is that when you've got an input voltage, you can scale it and do all sorts of things like that. Now, because I'm a bit cramped here, I'm not sitting in the chair, so I'm sort of bending down a bit. It's a bit awkward, but so we can do like a clear, so it resets the graphing and then it will start again. This is under the display menu, so display's here. You've got the math button, display, so you do shift display, and that brings up the display function here. And then you can do different input types. Number is what it's normally on. Right, so that's what it's normally doing, is the voltage in this case. But you can change the display to bar meter, so that's the voltage and bar, as you can see. So you've got something rapidly moving around. Maybe it will show up, I'm not sure, I haven't tested that part yet. The trend, which is obviously what this is doing here, showing that trending. And a histogram. So if you've got lots of fluctuations in voltage, it'll show up. So as it drifts up and down, it will change the histogram. I haven't played with this yet, but this trending chart is quite nice. I quite like that. It's a nice feature. Vertical scale, you can adjust it so it's automatic. So, well, default is the default setting, at least it appears to be, which is based on the range it's in. So plus or minus 2 volts is shown right there because it's in a 2 volt range. We do auto, which automatically scales the vertical scale depending on the input range. So as it goes bigger, the scale changes. So right now it's showing 991.5, 958 millivolts to 992.0089 millivolts. So that's the scale range. So it looks really bad in fluctuation, but actually it's not much at all. What we're talking there, what's the deviation? Minimax, here we go, deviation, standard deviation is 0.000128. So that'd be millivolts. So what's that in microvolts? Not much. Unless I'm reading that wrong, this is volt scale, then millivolts in, yeah, it might be volts. Yeah, it'd be volts readings. So that's relative to volts. So that is about 13 microvolts? Something like that. Yeah, be about it, wouldn't it? Millivolts. Yeah. No. 130 microvolts. Yeah. Anyway. It's fluctuating a little bit. It's fine. But what I wanted to show is, just that feature of this meter, which is quite nice. It's go back to that, and we'll go back to number. Right, so now you can actually see this meter now. Bit better, isn't it? So now we've got the Fluke 8842A, which is showing 99.205 roundabouts. The HP 3478A is doing 99.197 ish, 198. Obviously you can see this one here, so 99, or yeah, 0.99200, yeah, roundabouts. Getting the noise and helping that. I'm going to change to a different voltage source soon, but I'm just trying to show the relative measurements at this level. But then I'll increase the voltage on the power supply and you can check the scaling. So this is the Fluke here, it's a 5.5 digit. This HP is a 5.5 digit. That Fluke over there is a 5 digit, and the Vici is a 5 digit, or 4.5 digit or something like that. Okay, and this is obviously 6.5. And of course the EEVBlog meter, don't forget that. That's the datum, that's the one which is going to be right. That says 991 millivolts. So that does actually agree with the HP here, and really closely to this one, but not quite. I mean, it's 1 millivolt or so. That's pretty good, really. So this Fluke is currently agreeing with that Fluke, and currently agreeing with the HP. So I mean, they're really close. There's not much in it at all. And now this one, so this is agreeing as well. So there's just slight rounding things, it's a bit of rounding errors. I mean, that's probably just towards the top end of 991 something. It's probably got a 916 or something. But it's a bit hard to say, but that's not too bad. So what I'm going to do now, and also the Vici is 991.6. That's always been lowest, that one there. At this group, that's been the lowest. So let's try high voltage, and we shall go up in 1 volt steps, I think. No, let's go. Let's try and figure out the ranging on this thing. Alright, so I know this is 2 volt ranging. I think that's 3 volt ranging. Yeah, that's 3 volt ranging. Okay, so that's different ranging. That I think is 2 volt ranging as well. Let's have a look. So I'm going to try and get something which affects all the ranges. That's 3 volt as well. That's 30,000 count. Yeah. Thought I could get more resolution out of that thing. I might have to look at that and just see if I can get some more resolution. I thought it could. There you go. Do a slow update rate. Maybe that'll help. Yeah, there we go. There we go. Right, so that's now 100,000 count. Okay, so what's this set to? That's, yeah, it's slower anyway, it's okay. Right, so 3.99 volts, 3.9905, 3.9915, now it's higher, 3.9910, 3.9910, 3.9911, 3.990. So that and that agree. That's now higher, not lower. But it's still very close. And these three are basically the same. So that's not bad. I mean, there's only a couple of millivolts in it. There's not much at all. Well, sorry, about not even millivolts. That's what. That's about 50 microvolts. Okay, so let's go a bit higher. Let's go 9.99 volts. Now let's change ranges. So that's saying 10, because that's changed ranges. It's rounded up slightly. Actually, let's have a look at that and see what it ranges on that one. Yeah, okay, so that's 5,000 count. Alright, so it's also a little example of the counting and arranging, how the ranges actually switch over, I suppose. Right, so right, we'll keep going. We'll do that 99 volts again. Right, so saying, give it a couple of seconds to settle. 9.996, 9.9912. Big difference between those two now. About 4 millivolts. 9.992, so it's about a millivolt difference. 9.9925, so it's set 300 microvolt difference. Thereabouts. 9.9929, so it's that one there. The Fluke is very close to the Siglent, very close, and EEVBlog saying 10 volts because it's rounding. Okay, let's keep going a bit further. Let's go 14.99 volts. The reason I'm doing 99 is I want it to be at the top end of a scale, so you can get to see those different places rather than rounding too soon, that sort of thing. Okay, so that's why I've got that weird number there. It might be easier to read if I do that actually, if I do the round numbers. But we'll carry on. I'll start that now. I'll carry on. So 14.99 volts, 14.999, 14.992, 14.99604, 14.9956, 14.996, 1.5 2. So again, the Fluke A842 is very close to the Siglent, and the EEVBlog saying 15.01, so that's about 2 millivolts high right there. Okay, let's go a bit further. Let's go 19.99 volts. Again, let's give it a little bit of time to settle. So 19.996, 19.988, 19.99145, 19.9909, and 19.9917. So you can see there's this slight changes in tracking about where they're sitting. These two are still pretty close. They're probably the closest. The EEVBlog's saying 20.01. So that's currently showing the highest. And yeah, second highest would be the Vici. Yep. And the lowest is currently the Fluke 55. Not by much, so it's still. I mean, you see how close things are. The accuracy on volts is looking pretty good. Let's get 24.99. Right, so 25.005, 24.995, 24.9995, 24.9988, and 25.001. That's a bit of a step up at that one. That's changed now. Not by a lot. That's 600 microvolts. And 25.03. So now the EEVBlog is the highest again. But again, still, it's really close. I mean, there's really very little in it as far as accuracy goes in these ranges. So, again, I'm going to be hooking up to a voltage reference in a minute, which I've got sitting just here. I'll show you in a second. I just want to check it across a range of voltages above what my voltage reference here can do. Okay, so 29.99 is doing 30.015, 30.0034, 30.0082, 30.0073 and 30.009, and 30.04 on the EEVBlog. So it's still the highest there, with the second highest being the Vici, or VC, how you want to pronounce it. And what's the next highest one? Might be this one actually. That one, sorry, that Fluke there, then this one, then that one, and then that one. So you see it's not a linear range, is it? When you're going through them, you know, you see they're chopping and changing, which one's got the most relative reading, so, you know. Okay, so that's that part done. What I'm going to do now is hook up to this little voltage source we've got, which is, what's one of these little Chinese things here, from China, from AliExpress. These are the voltages, the outputs I've got on the back here: 2.49, 7.49, 4.999 and 9.996. Right, so it's using a AD584LH voltage reference. Okay, now obviously it's only just going to be turned on, it runs with a battery, so it's still pretty stable, right? So I've still got to warm up period and stuff like that, but because I'm going to be doing direct measurements simultaneously, that doesn't really matter in this case. Right. And here's the check sheet that came with it, which shows the voltages that it was measured as. Those are the set points, and those are what they actually produce, based on Agilent 34401A. Okay, it's back in August 2015 though, right? So, you know, it gives you an idea of what I should be expecting to see at least. Alright, so let's hook this up. It's currently set on the 10 volt range. It's actually set with jumpers, so it's a bit of a pain because you've got to sort of turn it off, change the jumpers around and put it back on again, but it's okay. Right. So let's flick it on. And let's see what we get. So this is supposed to be 9.99605. In theory, who knows? You know, temperature in here right now. I believe that is supposed to be temperature, measured temperature. So I think it's supposed to be 23 degrees, right? Temperature in here right now is 23.5. That's convenient. So, it's supposed to be 9.99605. So we've got 9.998. So that's about 2 millivolts out. 1.5 to 2 millivolts out on that one. 9.9946. So that is, yeah, about 1.5 millivolts out. 9.99622. So this one's the closest so far. That is, what's that, about 170 microvolts. 9.9958. So that's, yeah, about 130 microvolts, is it? 170 microvolts. No, even better than that, 70 microvolts. Yeah, 70 microvolts. So my maths is, it's been a long day. And 9.9963. So that one there is 300 odd microvolts different. you do the math, you can figure it out if you want. Alright, and the EEVBlog says exactly 10 volts. That's because of rounding and whatever, you know. It is essentially 10 volts, isn't it? Okay, so let's go to the next range. Now this one is supposed to be 7.5 volts, or 7.49567. So I'll start here again. That's 1.5 millivolts out. That one there is pretty close. 400 microvolts. No, almost a millivolt out, sorry. This one here, so that's 7.49575. So that's pretty close. That is 80 microvolts different. 7.4955, very close to this one, so that's slightly worse. So that's almost a millivolt out, about. Oh, what was I getting that one? 15675. Yeah, that's right. Yes, that's not too bad. And 7.498. So again, not too bad. I mean, they're all very, very close, you have to say. And of course, EEVBlog meter, which I keep forgetting, 7.5 volts. Essentially, it's 7.5 volts, so that's okay. Let's try the next one, which is supposed to be around 5 volts. And apparently, it's supposed to be 4.99944 volts. So that says exactly 5. 4.9986. So that's about 400 microvolts out. 4.9942, which is very close. Must have about 20 microvolts out. 4.9992, so that's about 500 microvolts. 4.9994, very close again. I've obviously run out of resolution, so that could be essentially accurate. So again, they're not all linear, they're all changing slightly. So that's also 4.998 on the EEVBlog. So that's about 4 microvolts, is it? No, microvolt out, sorry. 1 microvolt out. Again, so it seems to be about microvolt high in that thing, or just maybe slightly more than that. Okay. Again, that's not really much to worry about. That's, you know, that's only a small margin. So this one here is basically 2.5 volts. And here it's say 2.49829. So 2.4982, very close on that one, very close, the closest it's been so far. The Fluke 2.4978, so yeah, it's a microvolt and a half, 1.5 microvolts out, millivolts out, sorry. 2.49824, that's 50 microvolts out. 2.49822, so that is very close as well. That's 7 70 microvolts out. And 2.4982 also. So you can essentially say that's right again. So they are all extremely close, and 2.497. So this goes actually a little bit lower, not a little bit higher. It was before it's a little bit higher. So, yeah. But equally, I mean, if you're doing general measurements, any one of these meters would be absolutely adequate for general stuff. You know, there's the whole perception of getting hung up on the precision and having this super accuracy. And for most things, you just don't need it anyway. It's very rare for me to need any kind of precision like this. I mean, there's been times when I've needed it when I'm measuring, say, a VCO on a radio. You're trying to see any the slightest little voltage change because it is affected by these really small resolutions. But that's pretty much the only time that I would use them. Those precisions. And I've been times when I've needed to use this level of precision and not use those meters because those haven't been good enough. I had to bring one of these out. So it has happened. But yeah, this is very nice. I do like this unit. It's very good. So let's just do this trending here. Vertical scale. Get it auto, so it automatically scales. And let's see what it thinks of that. Just reset it. Now there's also a possibility, because we've got all these things connected together, there may be a possibility that there's some kind of interference between the units as well. That's possible. I wanted to do a parallel measurement all up, so they're all saying exactly the same thing. And you see there's a little bit of fluctuation here. But it's such a small fluctuation, it cannot even distinguish it on here. That's all those ranges there say 2.4982. I mean, it cannot actually get any more precise than that. It's not changing. Right? So within that scaling, that's it. As far as this is concerned, it's pretty much the same, just such minute changes, but it could be because of these other meters, putting a bit of interference out. So yeah, that's the DC voltage measurements. I haven't gone into any of the other settings on this thing yet. I'm going to go through and do a proper individual measurement thing on this and go through each thing and figure out, because I haven't played with this much at all yet. But also it's very similar. I mean, this actually looks very similar on the panel here to the Agilent, Keysight 34401, was it? Or 33? I did see a picture of one today and it looked very similar. The layout was almost identical. I think on some of these buttons they actually swapped the functions around, like your frequency and capacitance here, that's swapped over. I think this row and this row here were basically swapped over. Things like that, yeah, but it's basically the same layout. So they obviously seen a good layout they liked and thought, wow, we'll do that. And that's fine. They look very similar. I look at them, oh, that looks familiar. Anyway, right. So the next thing I'll be doing is doing some resistance measurements. I have to do that individually on each meter for obvious reasons. The only problem with that is that I like to do 4-wire measurements ideally, because that way you get the most accuracy, and that's what we're looking at after all. This does 4-wire, that does 4-wire, so does that, so does that. That doesn't, and neither does this. So I might have to scale it back and just do 4-wire on the ones that can do it, and only do 2-wire on the others. Obviously it means the others won't have as much accuracy, but we're kind of expecting that anyway. But I have to do individual hookups to each unit individually and do it, because obviously you can't parallel those up. It just doesn't. That just won't work. Okay, so I shall stop it just here for now. Okay, so I've put the wires up. You have to excuse the ugliness because these are some I've made up. Got some Kelvin leads on here. Okay, so it's all good. So I've got those shortened together. So I'm just going to try and null this out. I kind of have it ready, but it's a little fluctuation here, which might make us a little bit interesting. I mean, it's zeroed there. Now the parts I'm going to use for this are some 4-wire resistors. So we've got two to choose from. They're both Vishays. One's a 15 ohms and the other's a 20 ohms. Okay. I think I'd probably just do the 15 ohm. I mean, I'm using the Kelvin leads anyway, so I'm just going to do it onto there. So it may be affected by that. If this doesn't work out quite well, I might have to change to individual leads and actually use all 4 wires. Okay, so we'll try this and we shall see what we get. So I'm going to go into the end connections. Alright. And again, like I said, I was getting that variation. Might be a bit of electrical noise in the ear or something like that. So I'm saying 15.0063 ohms. Okay. If I change terminals, let's go to the next ones in, just in case it matters. Get on there. Yeah. Might be from me holding that heatsink is actually affecting the temperature as possible. That's changed very slightly, but yeah, it's a bit of fluctuation, but it's not that bad. Okay, so take that back off. And I actually mistakenly said that the Fluke 45 is 4 wire, it's not, it's only 2 wire. Okay, so low sense. Ah, of course. This one doesn't fit in there. Got different jacks on there, can't do it on that one. This might be interesting then. Might have to do a different method on that and compare it. Okay, let's zero this out. Okay, do the same again. So 15.002.001. So it's not bad, pretty close. How am I going to do this thing? It's going to be interesting. I'm going to have to use a different cable because that definitely doesn't go in there. Why do I have to do such a weird system on theirs? I don't know. Well, what I can do then is, for the time being, I'll do a 2 wire on the other 2 units and we'll see how those come out. Already got set on ohms. Zero that out. Again, straight away you can see the difference between 2 wire and 4 wire accuracy. That's much further out than it was on these ones. Relative. And you see it's given a slightly higher resistance reading there. They're still settling a little bit. It looks like it's probably about it. So it's given a slightly higher resistance reading, but it's still, you know, pretty accurate, even though it's only 2 wire. Now do the Vici and see what that thinks of it. Fortunately, the Vici doesn't weigh very much, so when you plug things in the front which are tight, because the sockets on this thing are quite tight, it tends to move the thing around. Alright, so you want resistance. Zero it out. settle. Very close. Let's check the zeroing again, just because I don't trust the zeroing on this particular meter to be good when you move things around. Yeah, that's right. So, okay. I mean, it's I'm reading slightly low, but it's not bad. I mean, for 2-wire, it's not that bad. You know, I think having these kinds of clips helps actually. Right, so there's the HP to try and figure out how to do that one. I'm going to have to use a 2-wire lead, I think. Let's have a look at that. Okay. Yeah, can't use that one. Yeah. What do I have that I can use? I'll have to come back to this one. In fact, I will. I'll be right back. Right, so I've got this 4-wire arrangement here. I'm trying to null this meter out. It doesn't actually do nulling from what I can remember or see. I can't see any way. It's got an auto zero thing here which you can turn on and off. It doesn't seem to do a huge amount. Right, so if you remember that value there, it should be right. It's negative 65 or so. Alright, so we'll hook this up and I'm going to do, I'll pop a 4-wire. Since I've got 4 leads, I'm going to do 4 leads onto the actual device. 1 on each wire, which is kind of the way it's meant to be used. Alright, so that's showing 14.998 or thereabouts. So that's a bit different, isn't it? That's probably, mind you, it said negative, didn't it? So I have to add on 0.0065, which makes it a bit higher, which makes it 15.004 or 5. Yeah, 15.005 effectively. So let's do it on 2-wire instead. I'll just leave it hooked up, it probably won't matter. And that's that much. So I mean, 2 wires are very different, as you can see. So that's a really hard comparison on this one because it doesn't have that offset feature on there. At least not that I can find. So yeah, that shows the resistance relative across the meters. I should check the EEVBlog one too, shouldn't I? Let's turn this on. The resistance. Resistance. We'll see what it thinks of it. So I'm just going to stick it across 2 of the terminals. 15 point. Oh, it's going down. 15. Yeah, fine. Let's have a quick look at the 20, so I've got a sitting right next to it. Yep, likes 20 as well. So, okay. I mean, they're all pretty close. You know, again, same deal. The accuracy is such a small variation, it probably doesn't really matter in most cases. Right, so I just started testing on these meters. I've just data chained them all, so they're all in series with each other. I'm doing a milliamps test right now. So that's at milliamps, that's at milliamps. This is on milliamps anyway because it only goes 2000. This is also on amps, but it does scale down to milliamps anyway. And the EEVBlog meter is on amps. Let's go milliamps on this one. I'm not quite sure what maximum range is actually on this one, but I'm only doing a very low level right now, so we'll see what we get. Okay, so there we are. Right, so 10 milliamps coming in, which first goes to this meter here, so it's 11.14, which then goes to the HP, which is 11.15, very close. Then goes to the Siglent, which is 11.1415. So these three are agreeing really closely. Then goes to the EEVBlog, which shows 11.15 as well. Again, very accurate. That then comes over to the Fluke 45, which is showing 11.1415. Again, very accurate. And comes over to the Vici, which is then about 11.1413ish. It's a little bit lower. Okay, but as you can see, these are all basically very similar levels, so no problem at all there. Okay, so I'm not quite sure what the maximum ranges are on these things. This is 100 milliamps. What's that one? That's 800 milliamps max. I'm not sure what the maximum is on that one there. These will be okay because 1 amps ranges anyway. Just have to be sure I don't go above at least 100. Right, so let's scale this voltage up, sorry, the current up slightly. Let's go to say 50 milliamps. And so 51.43, 51.38 V7, 51.39, 51.4. So there's a bit of difference there now. 51.38, 51.37. I mean, they're all still, you know, what's that, 20 microamps or something apart. So it's, you're talking about a very small variation still. Let's go up to 90 milliamps. Right, so let's just change scales. I'm not going to do 100 because of it's on the limit of that Fluke. I'm not sure what this EEVBlog can do. I can't remember what it can do. Probably does say on there somewhere. 600 milliamps. There we go. So it's okay. It's within the range of that one. But I'll go to amp scale next. So we've got 90 there. Do 92.08, 91.95, 91.99. I'll do all close to 92. It's fluctuating very slightly. Again, you've got this thing where the output regulation on that power supply is changing very slightly. 92 on the EEVBlog, 91.99 on the Fluke 45, flicking 98, and 92.04 on the Vici. So again, they're still very close with each other. So I'm going to change these ranges around now and come back. Right, so I just started testing on these meters. I've just data chained them all, so they're all in series with each other. I'm doing a milliamps test right now. So that's set milliamps, that's set milliamps. This is on milliamps anyway because it only goes 2000. This is also on amps, but it does scale down to milliamps anyway. And the EEVBlog meter is on amps. Let's go milliamps on this one. I'm not quite sure what the maximum range is actually on this one, but I'm only doing a very low level right now, so we'll see what we get. Okay, so there we are. Right, so 10 milliamps coming in, which first goes to this meter here, so it's 11.14, which then goes to the HP, which is 11.15, very close. Then goes to the Siglent, which is 11.1415. So these three are agreeing really closely. Then goes to the EEVBlog, which shows 11.15 as well. Again, very accurate. That then comes over to the Fluke 45, which is showing 11.1415. Again, very accurate. And comes over to the Vici, which is then about 11.1413ish. It's a little bit lower. Okay, but as you can see, these are all basically very similar levels. So no problem at all there. Okay, so I'm not quite sure what the maximum ranges are on these things. This is 100 milliamps. What's that one? That's 800 milliamps max. I'm not sure what the maximum is on that one there. These will be okay because 1 amps ranges anyway. Just have to be sure I don't go above at least 100. Right, so let's scale this voltage up, sorry, the current up slightly. Let's go to say 50 milliamps. And so 51.43, 51.38 V7, 51.39, 51.4. So there's a bit of difference there now. 51.38, 51.37. I mean, they're all still, you know, what's that, 20 microamps or something apart. So it's, you're talking about a very small variation still. Let's go up to 90 milliamps. Right, so that's just change scales. I'm not going to do 100 because of it's on the limit of that Fluke. I'm not sure what this EEVBlog can do. I can't remember what it can do. Probably does say on there somewhere. 600 milliamps. There we go. So it's okay. It's within range of that one. But I'll go to the amp scale next. So we've got 90 there. Do 92.08, 91.95, 91.99, 90, all close to 92. It's fluctuating very slightly. Again, you've got this thing where the output regulation on that power supply is changing very slightly. 92 on the EEVBlog, 91.99 on the Fluke 45, flicking 98, and 92.04 on the Vici. So again, they're still very close with each other. So I'm going to change these ranges around now and come back. Okay, now I'm going to put it up to the amp scales and rescale the appropriate meters. Still 90 milliamps, so let's increase that now. Let's go to say let's go 200 milliamps. Okay, it's a bit of a step now. So we're getting 202.7, 202.4, 202.5, 201, 202, 202.3. So I mean, again, they're all very, very close. As far as the actual, you know, this level goes, they're all the same pretty much. It's 202 on the EEVBlog now. But you can see the resolution thing here going on, but they're all very close, but the resolution is shows that you can't really rely on that. You know, they're all changing by quite a lot. I mean, these are both good meters, as is Siglent. You know, it's brand new, so it should be really close. You know, being calibrated and stuff like that recently. Where these haven't been calibrated for some time, so you never quite know. But I mean, that's in between these two. So I'm not quite sure what the actual specs are on these for the accuracy. It might be 1% or something. If that's the case, then it's well within. I don't know. 0.1% would be within. So let's have a look. Let's go half an amp. Right, so here we go. 500 millivolts. We've got 505.49, 504.5, and 504.8, 504, 505, 504. Again, they're all within a millivolt, or sorry, a milliamp of each other. So the the accuracy there between them really is pretty good. Again, you got these differences. So again, this is the problem we have with meters when you're doing this kind of metrology testing. Which one do you believe? Which is the right one? You know, just because you got a lot of decimal places doesn't mean it's correct. Yeah, it should be more correct, but you just don't know, do you? So, I mean, I'm going to assume this one is correct because it has the extra decimal place, and that's recently calibrated because it's new, whereas these haven't been. So this is what I'm going to say is the correct unit. Of course, I did say at the very beginning that EEVBlog is the one to trust by, but in this case, it's, well, it does agree, but it's not enough. Not enough digits on it. So, right, let's go a bit more. I'm digressing slightly, waffling. Let's go 1 amp. Right. So they're agreeing very closely again. So 1000 milliamps, so 1 amp. So that's 6.8, 5.2, 5.5, 4, 5. It's got 6 on it, and that's got 5.2 on it. So again, they're still very, very close. What's the maximum I go up to? I think I'm going to go up to 2 amps on this one here. That's 20 amps. That is, I think it was that 10 amps? Yeah, that's 10 amps on that one. This is, I think that's 10 amps as well, remember, on this thing. This is 3 amps, and this is 10 amps as well. So the lowest value I've got here is 2 amps. I can't go any more than 2 amps on this unit. So once I get above 2 amps, I have to scale it back a bit. I can't go much more above that anyway on this power supply. So, right, let's go 1.5 amps. Difference is changing slightly more now, so checking for cables warming up, you never know. Right, right, so 1.498, 1.496, 1.4965, or 69 that one is. 1.496, 1.497, 1.496. Again, they're still within a milliamp of each other. You know, they're still across the board very close. Yeah, well, that's about 2 milliamps between those two actually. But there could be a rounding thing there too. So yeah, but say 2 milliamps between those. That's the worst case right now. Right, and it's probably because it's warming up as well, because I'm putting 1.5 amps through. It's probably affecting it slightly too. So let's go 1.9. I don't want to push this meter too much. Right, so 1.901, 1.900, 1.899, 1.899, 1.900, 1.899. Again, very close. So now I'm at the point where I can't put any more power through this meter here. So what I'm going to do, let's pull this here, plug it in that piece, that'll be fine. Right. I can now go up to 3 amps because that's the maximum on this meter. Well, actually, I might just give it a bit of a little cool off period there. I'll shut it off for a second and let it cool down. I don't like to run things at high currents for very long. I don't want to damage any of the meters. I mean, they should be able to do it anyway, but things warm up when you're running currents through, because it is a resistor inside the units which is sensing the current. So I just don't want to stress anything. So I'll just give it a minute to cool. What should I set for voltage and currents? Let's go to 2.5 amps. Actually, no, I'll save some time. I'll go to 2.9 amps. I'll do that, which is the max this one can do. And then I'll take that one out of line and we'll carry on. I think this can only do 3 amps anyway, actually, on this single output like this. Oh no, 5 amps. That's right, I can go to 5 amps on that one. It's okay. Alright, so if I need to, I can parallel outputs on the power supply and generate more power. I don't really think that's going to be necessary. Right, that'd be enough cool down time. So 2.9 amps. Let's see how we go. So I'll just ignore this meter now, because that's no longer in circuit. So 2.906, 2.903, 2.904, or 3-ish, 2.906, 2.903. So we do have a range there now. This one is actually agreeing with the Vici, which is quite interesting. What's that, 5 or 6 milliamps difference now? Now we're getting up in ranges. But it does agree with that one as well. So we've got 3 meters here which are basically agreeing, and we've got the other 2 meters which are agreeing. So yeah, you go figure. Let's go. That's as high as I can go on that meter. So let's pull this one out of circuit and step it up a bit. Let's go 4 amps. Right. So we have 4.007, 4.007, 8-ish. I mean, it's rounded, with rounding it would be 8, wouldn't it, on here? 4.01, 4.007. So the Fluke is reading a bit higher. But again, not bad. So let's go straight to 5 amps now. I don't want to do this for too long. 5.1 amps is the maximum power supply I can do. Let's have a look. 5.09, 9, so just about 5.1, 5.1 there, 5.102, 5.099. So these again agreeing very closely. It's like 990.4, 99.3ish in stuff I'm seeing just now. So they agree very closely. Right, let's see, I'm going to drop that off now. Okay, so yeah, as far as current ranges go, on DC at least, obviously I haven't done AC testing, they all look pretty comparable. I mean, I can't say about the resolution and the accuracy of the resolution on this. I don't have anything to test this. Although that said, I've just purchased something on eBay, but it's going to take a couple of weeks to arrive, so I doubt I'll have it in time to do the review part of this. I'll probably have given this back by then. It might take 2 or 3 weeks to arrive. We'll see how we go. If it does come in time for I have to send this back, then I'll pull this out and get this other unit going. Although it's supposed to be maybe faulty, so I might have to fix it first. We'll see how we go. Okay, so I think that's about the DC side of things covered, from what I can do for basic testing at least. If I go to display, again I expect it's got these trending and stuff in here, so if I go in here and I'll turn it on for a start, go in here, drop this current down, you should see it trending down, or up, whatever it's going to do, I don't know. Oh. What's that doing? Oh, of course, yes, right. It's going upwards because I have everything connected backwards. It's already negative, not positive, right? Just, yeah, that's why it's going the other way. Anyway, don't worry about that. So, yeah, you got histograms and stuff like that in there. It's got some nice features. So, right, I think that covers that part for now. If I think of something else, I'll do it. Right, so I put everything away, then I realised, there's another test I can do. AC volts, I can do that test. I can generate AC with my audio signal generator, well, audio generator thing, goes up to 1.3 megahertz, so it should be ample for this. It does sine wave output, so that'd be absolutely fine. I can change the frequencies to see how they respond to frequency, which would be a nice little test for them all. So I'm going to I thought I'd do a boot up sequence. Okay, so let's boot them all up and you look at the startup times. Here's a Fluke. It's ready. Here's the HP. It's ready. Here's the other Fluke. A little bit longer. It's ready. There's the Vici. It's ready. I'm just going to turn the backlight on so I can see it a bit better. And of course there's the EEVBlog, which I'm going to do on AC volts when I get there. Okay. Where do I use this thing? AC volts. Here we go. All right. And then of course the Siglent. Now, being computerized and having a display, it does take longer. It's like any other piece of modern equipment which has got displays like this on it, but it did take a bit longer to start up compared to everything else, as you can see. All right. Is it an issue? No, I don't think so. Just one of these things, you just leave them on for more time. But okay, so everything's now booted up. I'm going to boot up the my Rohde & Schwarz Polarad signal generator. And I could use the AWG, which is built into my scope, but again, because that's a digitally generated AWG, there might be some little steps and stuff in it. So I thought I'd use a Polarad instead, because I know that puts out a reasonable signal. All right. So that's 10 kilohertz frequency right now at 1 millivolt. So let's set all these scopes to AC. Let's see, here we go. So that's AC on that one. That's AC on that one. That's AC on that one. One thing on this, I've noticed that the buttons, you do tend to need to push them harder than normal. I don't know, maybe it's getting better now I've been using it a little bit. But initially it took a bit of a push to get things to actually respond. So it does seem to be improving now, so it might just be a new thing, but it's brand new. That's a bit in a bit or something, I don't know. AC volts. AC volts. Okay, so now the Vici's looking a bit out of whack there compared to everything else. Hold on, let's try and get this ranging right on this thing. Playing with the button, wasn't I? What have I done with this thing? What have I done to it? So I haven't used this thing that much. Must be an automatic setting, surely. Oh, I've stuffed it. Auto, there we go. Right. On auto, but it's not seeing it. Alright, so if I go to the correct range, it'd probably be better. Millivolts, there we go. So it's slightly better there. Alright. Yeah, you can see that okay, can't you? It's not shining too badly. I'll bring it around slightly this way. Right. So again, that's 1 millivolt being generated at 10 kilohertz. So that's showing 1 millivolt. That's showing just under a millivolt. That's showing just over a millivolt. That's showing 1.02. That's, yeah, showing 2 millivolts kind of. And that is showing, well, nothing really. 0.02, which doesn't really correlate. It's probably the frequency is too high for it, I'm guessing. Okay, so what I'm going to try now is change the frequencies. So if we go down to 1 kilohertz, same voltage. Again, pretty good. Alright, they're still very close. I mean, this has gone a bit higher now. This one's now showing a frequency, showing a voltage, 0.97. Obviously the frequency was too high for it before. I should actually do frequency measurements too. Some of these things can do frequency, so that can do frequency, that can. I think this can. Pretty sure, so yeah, it's frequency on there. That could do frequency as well. So I'll do some frequency tests as well, just to see what they show as well. Okay, so the Vici is still not really showing much. It's closer, but it's, no, you can't really rely on that too much. Right, let's go down to 100 hertz. Nice common frequency. And there we go. EEVBlog meter is now bang on. The Fluke is close. Siglent is still slightly high. HP is close still, but still under. The other Fluke say 106, and that Vici is 1.1 millivolts. So again, they're all very close to each other. There's not much in it. Alright, so let's go down to 50 hertz. And again, all very close. That's increased slightly, this one's increased slightly. In fact, so is that one. Hasn't really affected this one much, that one's still about the same. Okay, so let's go to a higher voltage level. Let's do 100 millivolts, still at 50 hertz. And see how that compares. So 99.4, 99.4, 99.5, 99.5, 99.3, 99.45. Again, they're all very close with that frequency. So let's just try 100 hertz again. And again, still very close. They're starting to get more agreement actually. Slightly higher frequency, 99.34, 9.3, 9.3, 9.4, 5-ish, 9.3, 9.4. So very close. Okay, let's do 1 kilohertz again. Hasn't really shifted by much, so pretty much agrees to that frequency. 10 kilohertz. EEVBlog's dropping off. This one's okay. This one, these two are fairly good there. The Vici looks like it's dropped off a little bit as well, but the other 4 meters here look pretty reasonable. So let's go a bit higher. Let's go 100 kilohertz. That's completely gone off now. Vici's dropping off. These are still looking good. See more difference between them, a bit more variation. Let's do 200 kilohertz. Okay, now we're getting some differences. That Fluke 45 is dropping off. Interesting, the EEVBlog's coming back up. This is dropping down a little bit. That's come up slightly, and this one's still reading fine. Okay, let's do 300 kilohertz. Still good. These two here. Those others are all dropping off. So these two here are doing the best so far. 400 kilohertz. Still good. Started dropping. And these others are all unreasonable. So let's try 500. Okay, so 500 kilohertz, the signal's still going. All the others dropping off still. 600 kilohertz. Still good. The others are still dropping off. We're going to go to 800 kilohertz now. Starting to drop slightly. 1 megahertz. And that's starting to drop down. Alright, so this is obviously getting towards the limit of what this can do at 1 megahertz. But still, not bad. You know, you don't tend to get that anyway, so it's fine. And interestingly, with that frequency, these meters here are agreeing 19, 19, 19. What a coincidence. Okay, so now we'll look at, we'll go back down to 50 hertz again, and I'll increase the voltage to 1 volt. So that's now a range on that one. Let's bring this up. So where are we? 9966, 9967, 9966. Hey, these two agree. 997, because of rounding and stuff like that, I expect. 996 and 1.000, whatever. Right, so again, still very close. I mean, this is really showing that no matter what meter you buy, the accuracy these days is actually pretty good. You know, they're all very close to each other, to the point where you have to wonder what's the point of spending huge amounts of money, unless you need that accuracy, of course. You know, absolute precision. For normal bench stuff, most people just doesn't need to have, you know, 100 microvolt accuracy and stuff like that. You just don't need it. Okay, so that's 1 volt. Let's do 100 kilohertz again. Oh, that one there. And that's dropped off as expected. Yep, okay, correlating. That's dropping down, that's dropping down. But these are closely in within a millivolt. This one here is a few millivolts down. At 10 kilohertz. So that's still off. That's working, all these are working. So 10 kilohertz seems pretty safe for all these meters, but it's not the EEVBlog one. That seems to like a lower frequency. Let's just try 5 kilohertz. And 5 kilohertz is starting to work on there. 2 kilohertz. Yeah, it's close. So it might be only 1 kilohertz rated, really. I don't know, 2 kilohertz didn't really change much, did it? It did drop down, so 1 kilohertz looks like the rating for that one, really, for that EEVBlog meter. And the others are still going just fine. Okay, so let's go, actually no, let's go 5 volts. Maybe. What am I doing wrong here? Hold on, I'm just messing myself up. Here we go, 5 volts. This is still at 1 kilohertz. Alright, so 49994, 4988, 4997. So that's, those two are pretty close. Well, it's just shifted slightly now. Must have settled a bit, so that's 5 volts in it. So we've got 4.922 on the EEVBlog, 4.998, 4.994 there. So again, they're within a few millivolts of each other. Do 100 hertz. And there we go, 5 volts there again. 4994, 5999, 4997, 4991, 4997. So there's not much difference there, right? So 10 volts. Still pretty close, it's about 4 millivolts difference. 6 at worst, I think. No? Yes, 5 millivolts worst error between. Oh, sorry, that one there, 6 millivolts. No, it's 200s. That was the worst error there. So I've got 10 point, so it's like 3 millivolts there, 8 millivolts, 4 millivolts, nearly 5, that's 7 millivolts, that's nearly 6, and that's 20. So the EEVBlog there's got the worst error at that range, at that frequency. Alright, so let's say it's 100 hertz. I think that's probably enough, is it? Do you think? Or 20 volts. Oh, volts, not dBm. What's the max this thing can put out? I don't know now. I seem to have just stuffed myself up there slightly there. Hold on. Just got mixed up. There we go. I think 10 volts might be the most I can do actually on this thing. Yes it is. That's the most I can do is 10 volts. So that's it. Right. That's sort of testing on those then. I suppose I could do another 100 kilohertz test at that voltage. There we go. Again, the EEVBlog dropped off. Got 10 volts there, 10 volts there, 10 volts there, 9.8 there, 9.6 there. So yeah, that 100 kilohertz is where these things start to struggle. I'll go back down to no, let's do 300 kilohertz again. So those are dropping off, this is dropping off, and these are still going. So this one here is lasting the best out of all those. So if you need to capture a wide frequency range, you know, into hundreds of kilohertz, then this is the one you want to get because it can do it. 800 kilohertz, it's still there, and all the others are gone. So that's good, you know, if you want to do that kind of measurement. Alright, so let's drop this voltage down. I'll try and drop this voltage down. There we go. And you can see it's, you know, this is the one which is reading right still. So what I'm going to look at now is frequency, so I'm going to pause this and come back. Okay, so I've set the meters that can do it onto frequency, which is the EEVBlog, Siglent, the Fluke and the Vici. Right, so the Fluke 45. So these are the ones which can do frequency. So I've still got 800 kilohertz at 1 volt. This is reading okay. So is the Vici, so is the Fluke 45. EEVBlog currently cannot see that frequency. I believe it probably goes to a kilohertz based on display. So ignore these meters for now because they're not on frequency sensing at all. So let's change the frequency, go down to 500 kilohertz. Still fine, still fine, still fine. Still nothing on the EEVBlog one. Okay. 100 kilohertz. All good. All very close. Still nothing on the EEVBlog. 10 kilohertz. Yep, still all good. Still nothing on there though. I'm a little bit surprised by. I thought I'd be seeing something by now. Looks like I might have got the wrong setting on there. So again, this is now 1 kilohertz. So very close. I should actually hook up my frequency counter, proper frequency counter, and see what it's actually doing as a comparison. I should do that, shouldn't I? I'll do that afterwards. Okay, 100 Hertz. Still getting nothing on the EEVBlog meter. I'm wondering why. These are reading okay, as this one here. So far the frequencies are all, you know, within a few hertz. I mean, they're close. I mean, that's what you expect. But why is this one not showing anything up? Have I got something set wrong on this? I might do a disjustice to this thing. Yes, I am. It looks like. Now I'm getting a reading. So we shall look at this again. Alright, so that's 100 Hertz on there. Okay, so we'll just quickly do the other test again. 10 kilohertz. Yep, it's there. 100 kilohertz. It is there. Okay. 200 kilohertz. It is there. Can read it. 500 kilohertz. Can't read that. Okay, so the EEVBlog can't read that. Let's go 300 kilohertz. It's there, right? Yeah, that's about it though. Can't be 400. So 300 kilohertz is like the top end of the frequency reading on that thing. If you want reliable readings at least. Okay. So yeah, it can do it. I just said it's set wrong. I don't know what I'm doing with it. Apparently. Okay, 100 Hertz again. That's all good, and 50 Hertz. All good. So they are reading pretty well. So what I'll do is I think I'll hook up one of my frequency counters, which I'll better power up, get it kind of warmed up, and try and connect into this somehow. I'll have to figure out I'm going to do that, and show the actual frequency if I can. Right, so I've got my frequency counter hooked up. It's kind of mishmash, but it's clicked on and it's reading frequency. So that is reading currently 49.9998 or thereabouts. Let's adjust this gate time very slightly to get a slightly better sampling. Okay, so that is no point looking at that one. that one agrees. That one's a bit low. That agrees pretty much. I mean, this is rounded up. You're talking about what's that? Microhertz, a few microhertz. I mean, yeah, it's tiny. Okay, at that frequency anyway. So let's just increase this frequency. Go 1 kilohertz again. All right, so I'm reading 999.992 ish. Kilohertz. Hertz, sorry. Right, so it's just below 1 hertz, 1 kilohertz. It's 8 hertz below. So I think the sampling time on this is what's maybe throwing this one. Let's increase that slightly. Let's go 1 second. Now increase the accuracy. There we go. Right, so that's pretty close. It's out very slightly. Again, jumping around, but the gate time is, you know, affecting that, I'm sure. But it's very close. It's really small amount out, and that just says 1 kilohertz, and that is a bit low, and that's saying 99.9. With rounding, it should probably be saying 1 kilohertz, but anyway. Okay, let's do 10 kilohertz. Now I'm getting 9.99992. So it's 4 nines and 2. So that's out slightly by say 30. Is that 30 microhertz? Is it? I don't know. I'm losing track now. It's not out by much at all. I need to turn those off. I'm not using those anyway right now. Well, that still says 9.999, it's good, and that is slightly low, and that says 10 kilohertz, so it's all fine. 100 kilohertz, getting 99.9992. Again, it's just slightly out there. All right. Again, not by much at all. And these are pretty much agreeing. So the actual frequency accuracy of this is not bad at all. It's, you know, considering the levels I'm actually measuring at. Let's do 1 megahertz, which is where this one started to be. Well, that's why I ran out of limit on the other thing. That's right, on my tester there. It only goes at 1.3 megahertz. I can go slightly higher. Okay, so that is still measuring. That's really 1 megahertz. That's doing quite nicely actually. There's 99.68, 99.99578, and it's 999.992 still. So again, it's a slight difference in frequency there. Let's increase this level here. Let's go to 1.1 megahertz. And all of them are still reading at least through here. They can still read that frequency okay. Right. And it's doing 1099.9912. If I increase my gate time on my counter, I'll be able to see a bit more detail, but I think that's enough. Okay, so it's very close. Again, still out by about 3. In this case, last significant digit. So, and that one's still out by a bit too. So, yeah, they're all very close. 1.2 megahertz, still there, and still very close. Still about 3 out here. And my maximum on this particular tester, 1.3 megahertz, and I'm getting 1.2. Well, yeah, 1299.989, or 1.2999, pretty much. 1.2993, 1.2995, 1.3. So that's reading slightly high, that's reading slightly low. This is a fraction high, not much. So yeah, I mean, it's not bad at all, really, is it? EEVBlog has completely gone ages ago. You know, back down 1 kilohertz again, and all good. So this is reading very well. Now, considering it doesn't have a 10 megahertz calibration on it, it's pretty accurate, really, you have to say. Right, so I'm going to look through some more of the menu stuff on this. Now I've done all the comparisons. Now I'm going to start going through the menu system and trying to cover what I know, and hopefully some of the things I don't know, and maybe pick up on those later on. I'm quite keen to get a video on this as soon as I can, because it's a fairly new unit, I believe. Okay, so this is on the DC volts range here, and you got options here. You can set the ranges here manually or automatic. You know, automatic's pretty quick. You can see the update rate here. You can actually adjust that. It's aperture setting. I think that means 10 places. I'm not sure what PLC means. I should really read that. Do 100, it goes much slower. So I think it's more like samples or something. So you can get a much higher resolution. If you go right down here to 0.05, you can see how quickly this updates. So you can see some massive speeds there. So if you need a fast update rate, you can just change this setting here and get a faster rate. I believe 10 was the default. At least that's what it came with when I started using it. Auto 0, I'm not really sure what that's doing. It does seem to slow down the update rate. I'm not quite sure on that function there. You can see it slows down a lot. So I'm not familiar with that. Relative, I mean, that works, but you know, it's right now I've got nothing on it, so it's not doing really anything, so it's just noise. Okay, that's that. Let's do DC amps. So you do shift and then the DC volts, because it's got DC amps just there. You can just see the sub dash ring there. And it looks like it's got the same options, ranges. And you can set your own range as well if you want, so 2 amps in it. And also you can do other range, so you can set. I think it was one of the features that you can set your own range, I think. Unless it just meant to extend the menus. So microamps right through to 10 amps ranges. Okay, again, you've got the PLC setting here for the update rates, it seems. Auto zeroing, I don't know, it seems to work better with that off actually, interestingly. And of course relative measurement as well. Okay, let's just put this back up to 10 again, slide that rate more. AC volts, I think it's all going to be very similar. Ranges up to 750 volts AC, and it has filters in here, so you can take out any like mains noise, I think, and stuff like that, or low ripples and stuff like that. I think you can take those out, which could be handy. I'm not quite sure what the default is supposed to be. Let's do that instead. Is that affecting the update rate? It is affecting the update rate, so I'm not quite sure what the significance of that is. You know, it's interesting. Okay, and AC amps, same options in here as well. So microamps through to 10 amps AC, and filters the same as well. So you've got the 2-wire and 4-wire resistance measurements, which we went through before. Again, range options here, 200 ohms through to 100 mega ohms. That's pretty big. 100 mega ohm range. And again, the places options. So down to 0.05. See the update rate, how quick that is now. You know, if I just sort of mess with the probes or something, it'll, I don't know. Anyway, we'll see. Right, and same standard features there. And we also got the 4-wire measurement, which we also used. And again, same options. And auto ranging also still the same ranges. Okay, so we got capacitance and frequency. Now, I did frequency before. I haven't done capacitance yet, so I'm going to grab a capacitor. It's supposed to be quite large ranges, so 2 NF up to 100 MF. Alright, what's that, millifarad? 100 millifarad. So yeah, that's quite a big range. So I've just got a go back here, leave it on auto. Short the leads together, is that doing anything? Nah, don't know, it just sits there like that. So let's try sticking a capacitor on here and see what comes up. $91 UF. Well, this is rated as a 50 volt 100 UF cap. See if it reads any faster if I put the range exactly in there and do it again. Yeah, see, that's faster like that. So if you know what the range is, then you can do a faster measurement that way. Okay, so that's that one. Let's go for something a bit bigger, shall we? What have I got here? About 15,000. Get the thing out the drawer will be good. Come on, come out. It's a bit stuck. It's a bit big, this one. Hold on. Right. So this is a 15,000 UF 35 volt. Alright. So we'll see how quickly it reads it without changing ranges. So it's still automatic. Now, being quite a big cap, it will take a while to actually charge it up, I imagine. It's supposed to be able to cover this range. Should be able to do it. Come on, you can do it. It's taken a while. Here we go. 14.3. Alright, that's how long it took on first charge. Alright, so if I now come over here and do a larger range, so that's 15,000, which should become under 20 MF range. let's short these out. Let's make sure it's discharged. So do exactly the same test again. Auto ranged. Well, not auto ranged. There we go. Found it straight away. Okay. So if you're not auto ranging, it will find it much quicker. So that's something to bear in mind. If you know, at least you know what value you're looking for, then that will work just fine. Okay, so that's that one. Frequency we've already covered. You can do frequency and period. I didn't cover that part of it, obviously. And ranges. Interestingly, it's got voltages there. Okay, let's try frequency. Range has got voltages. Why would there be voltages in a frequency range? This might be a bug. Perhaps Siglent can have a look and tell me whether that's supposed to be right or not, because I don't think that's right. Right? If you're reading a frequency, you've got a range, millivolts and volts. I don't know, maybe because it's based on reading AC frequencies? Maybe? I don't know, it seems a bit odd. It's interesting. Interesting, I don't know, is that right? Perhaps Siglent can say yes or no, because it just seems a bit strange to me. Gate time, 1 millisecond. Right up to 1 second. So if you want to need that extra accuracy, then you can get that longer gate time. That's not too bad. You've also got relative measurement as well, so you can do offsets and such. And frequencies, say the same thing in there, and that's the same as well, I expect. Yep. So it's all pretty easy. Okay, so next thing here is continuity, I guess. If I can push the button. Like I was saying before, these buttons you have to push them quite hard. But I think once you've used them a few times, they actually get a lot better. Alright, so that was a bit better that time. So I don't know, maybe it's a bit of a residual build-up or something on the circuit board, or perhaps on the carbon on the back of the buttons or something. But initially I'm having to push them quite hard, and then let's try again now. Oh, I'm still having to push quite hard there. Maybe there's something there, I don't know, but it did seem to get better when I was doing other stuff. So continuity, that's a bit slow. Sorry guys. So look, yeah. I mean, that's a bit slow. That could use being improved. I mean, it will do it, but you can probably see a delay there if I do it like this. Try and get in focus. Oh, but that miss. See, it's actually missing some, so it's not as fast as it should be. There's a threshold setting here. Maybe I need to look at that. Let's drop that threshold down. 0 ohms. Okay, if it's 0 ohms, doesn't work at all. I don't know. Let's try going up. Hold on. Let's go higher. How high can it go? I don't know. That's at least, it means you can set what value you want for it to trigger it. So that could be, you know, quite nice. It's getting faster. Maybe I just need to get this threshold set high enough. I think that might be close to the maximum. 2K is the maximum. It's faster, but still not fast enough. Sorry guys, I don't like that. That's not good enough. Yeah, that's just too slow. You know, it's okay. You know, it works, but it's a bit slower than I'd like. If you're trying to quickly go through testing stuff, that's a little bit laggy. So I'd like to see that improved if you can. And diode test. Oh, I need a diode first. Let me go and grab one. here's a nice big diode. It's not bad, is it? What was this thing? It's 6A6. Well, I've got no idea what that is. I've obviously bought a bunch of them for something. It might be a Schottky, I'm not sure. Alright, so diode test. Yeah, open that way, as it should be. And that way, that's fine. Was that faster? No, not really. It's a shame. Yeah, I mean, it works. It's a diode test. And you still have this threshold option here too, which is interesting. That's obviously for the activation of the buzzer and what have you, so you can set that what you want. Okay. We have temperature. Right. Temperature. This didn't come with a temperature probe, but I believe that my the ultimate meter may have a probe in here, which will work. Let's have a look. So this probe is from the EEVBlog meter. Okay. Which terminal is this going? I'm guessing it's the standard ones. It must be. It doesn't show temperature on those. Interestingly, let's plug it in. See if it comes up. It's working. I guess it's right. Yep. I mean, yeah. Okay, that's working. So yeah, this is a standard probe. I'm not sure which type it is. I don't know what any of this stuff is. Thermocouple, thermoresistor, JK. It's obviously all the different thermocouple types. I think. How do I do this? Read. Okay, let's go back here. It might be the wrong thermocouple type. Is it this button? No. There we go. Right. I believe it's a K-type. Is that it? No, it's not a K-type. Maybe it's a J then. I'm just guessing, of course. No, that's completely wrong as well. But interestingly, when you look at this, it still says bits over here, but the value's obviously changed. So I'm not quite sure what the actual display is supposed to be doing here. You expect it to be different to that. Maybe this is a reading standard. I mean, this one's unfortunate, isn't it? TITS 90. Yeah, no. Yeah, that's reading wrong as well there. That value was much closer before. What's different here? That's interesting. Still saying bits 90 though. This is different. Why has that changed? That's interesting, isn't it? The display isn't updating. I'm not sure if that's just dodgy or if it's. I have to use that one. Let's plug that back in again. So, in. No. This is interesting. So this isn't changing. This one looks closer. Oh, now it's changed. It wasn't changing before. Okay. I'm pretty sure these are wrong though. Yeah. I would have thought this would be a K-type. I don't remember what the EEVBlog one came with, but now it's reading correctly. Well, ish. So I don't know what's going on there. There might be some bugs with this thermocouple sensing. See, I'm on bits 90 now, and it still said RITS 90. So there might be a little bug there. Still RITS 90. JITS 90. still Ritz. Kits 90, still Ritz. Still Ritz. Okay. Nits, still says Nits. And I did that one, still says Ritz. Sits, still the same. So there might be a bug here with this thermocouple set up on here, because I can't seem to get this to behave the way you would expect. I'm guessing this means JK type and stuff like that. I mean, I'm not too up with thermocouple types. I do know there's a J and a K type, and there are others. But as far as the differences between them, I don't know. I did read then. Is that a difference? I have to do read, not done. It could be operator error, not bug. Right, so this is a K type, which is what I expect this thing to be. That's going downwards, so no, it's not. Okay, let's do a J then. It looks like it must be a J. There we go. That's what I'm doing wrong. It's me. It's going down as well. No, hold on. Let's do that. Yeah, look, there's a red dot on that. I should have noticed that before. There we go. Look, there's a red dot on here to tell you which way around it goes. Ah, dear. Okay. Now it'll go up. Look at that. Right, so it could be a K or a J type. Right, yeah. Right. There we go. So I'm doing. You have to do read, not done. Right. Silly me. Don't do what I do. Well, sometimes anyway. Right. Temper valve, measure valve. Oh, okay, so you can tell, it tells you the microvolt reading from the thermocouples. It tells you the voltage you're getting from it. That could be handy. You need to test things and verify that the microvolt you're getting is correct for the temperature. Celsius, Fahrenheit, and Kelvin. Cool. Let's go back here first and put this back to temperature value. Units, Kelvin. Here we go. That's handy too. If you need to use Kelvin rather than anything else. Right, now I'm starting to get a bit more sensible. Scanner. That is based on a expansion port that's in the back of the unit. I don't know much about that yet, but apparently there's like a card you can get for it or something. But there's very little information on that yet, at least that I've found. I haven't finished the manual. I've only read about 3/4 of the manual on this, so it could be that it's in there somewhere. But okay, dual meters. So you can choose what the other meter is reading. Let's go back to DC volts. Okay, DC volts. You have to be on a suitable scale for dual meters. So dual, then you can tell it you want to do AC volts. So I could do DC volts here, AC volts there, for example. But what happens then, you can hear it hopefully. Hear that clicking? It's switching between ranges. It's not two independent readings as such. It reads one, then it reads the other. It reads the other one, reads that one. Which is exactly the same as my Fluke 45 does. It does exactly the same thing. So it's not like a shortcoming in this, it's just the way that is implemented. I mean, the Fluke 45, I bought that because it's got dual meters. Which means you can measure like DC voltage and ripple at the same time. Really good for that. But this, I also can do the same thing, but it's switching from one to the other, as you can hear. Okay, and so back out of that. Utility function. I think we looked in there before. Store and recall, so you can save setups and recall them again. You can restore the factory settings. Security arrays. So because it's got that logging features and stuff in there, it's probably some military thing. I don't know. Set to defaults. Oh yes, that's right. Power on option. That's right. Set to defaults. This resets it. Okay. If you go back into utility again and store recall, power on setting. So it's either factory setting or last used. Okay. Same thing as the signal generator, which I just reviewed. Had on it as well. The same option. Okay. Managing files, so internal memory, so you've got display captures, empty folder stuff. Right, let's go. We'll go back from this. There we go. You can browse into memory, see what's in there. Just that for now. Back in again. Oh, I'm in. Sorry. In out config. So into the LAN on and off, LAN settings, GPIB settings, which will be via USB. So this is address you can set there. Test and admin. Ball test. Yeah, what the hell? Unplug that. So keyboard, LCD, beeper test, chip test, which I'm guessing be FPGA or something. Let's do it. FPGA, ADC, temperature, Ethernet. So it checks all its internal ICs. Cool. Beeper. Yeah, that works. LCD, I think it just does like a colour, so you can check for dead pixels, and keyboard is like individual buttons. I'm going to do that. And system setup. Choose language. Firmware update. Screensaver. It's currently turned off. I might set that to say 30 minutes, just for, you know, preservation of the screen. It's quite a nice thing. If it's not being used constantly, then it's a nice thing to check, just to increase the lifetime of the unit. System info. So here's the stats. So 9 startup time so far. And here's the details in this particular revision. Okay, so that's that. Acquire menu. This is one I haven't really played around with yet, which you have to push a bit hard because obviously I haven't played around with it much. You've got trigger source, external, automatic or single. So I'll just do one trigger and then stop. I'm not really sure what you need that for. If you want to take one single measurement, I suppose you're trying to capture an instance, for example. Delay time, you can set delays for the sampling, I'm guessing. And triggers and samples, 1, so I suppose that's like an averaging feature. So it'll average readings out, so if I increase that to say 10, maybe it averages it, I don't know, I was guessing. I should read the manual on that bit. VMC out, positive, negative. That is a connection that's on the back of the unit, which is like a trigger output, I think. So it's sent, so when it's activated, it sends an output of, I think it's negative. Well, obviously positive or negative. But I did read something as negative, but obviously here's an option to set that. Help system, of course, it has a help system. What should we look at? Math functions. Right. Bit of spiel there. Also, this is going to be in the manual as well, I expect. It should be. So, what does it do? Max, min, average, standard variation. Standard variation? I'm not quite sure what that refers to. dB, dBm, pass fail, relative measure, display function, histogram, trend chart, bar, meter, etc. Press the math function. Blah 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 blah. Shift math buttons. Yeah. Anyway, optional multiple scan card. Let's have a look at this. Optional multiple scan card. Press the shift and temp buttons on the front panel when the multiple will detect the installed scanner card. If effective hardware installation can be detected, the menu soft keys within the display will change in effective state. Otherwise, the message box function invalid will be ejected, really, and disappear after about 3 seconds. Wording here, Siglent. This is a bit Chinglish. A message box function invalid will be ejected. I think you need to say displayed. Okay, just a little note for yourselves. I'm sure you'll be watching this video. Anything else here? Oh, of course there is. Technical support. They've got that on all their meters, it's quite handy. Okay. Yeah. Done. So there's the math function in here. Statistics. I was using this before. It's quite nice to actually have that running. You can see the min and max and stuff like that. So that's quite nice. You can reset it. so you want to start again from the new values. Limits, I'm guessing it certainly looks within a certain range or something like that. I haven't played with that. You can set them on and off, and you can set center and span, or low and high. Yeah, I guess maybe it beeps or something outside that range, because it's got a beep mentioned here. So maybe it goes outside of that range, it'll beep. dBm, so it's display dBm instead, or dBm. It says dBm there, and there's dB. There we go. So you can see a 50 ohm based measurements, I'm guessing, and of course relative value. Just bringing this up here, so you can do an offset of some kind. Display, number barometer or bar meter. How quickly does that update? Right, maybe on this scale it's not doing that much because it's not got much range there. Let's chuck this on and do temperature again, and find the actual end of the probe. And yeah, I mean, I don't know, if you're trying to, I don't know, it's probably got some way of actually adjusting that range. Horizontal scale, default, manual, so you can set the range whatever you want. So if you want to see fluctuations, that's a bit easier, isn't it? Okay, I'll leave that on default for now. Okay, so back to display. Is anything else in there? That was it. Trend chart, obviously, so you can watch what it's actually doing. We used that before when I was doing the other measurements. And I think I did cover this previously. Yes, I did cover that. And display histogram. So it shows data points, I suppose, and occurrences of those data points. So how frequently those measurements appear. So that's quite handy if you're trying to do an audio measurement or something like that, I suppose. I'm sure there's other reasons for that. And back to number. Run stop. So if you want to freeze a reading, you can do that. Single shot. So there you go. It does a single one apparently. I don't know. It's also got hold as well, apparently, but it doesn't seem to do that. Maybe it's got something to do with the extra card or something. And ranges as well. You can do ranges on this too. So let's go. Sorry, back to temperature. Let's do it in this. It's got a thermocouple in there, which is stopped. So you can change ranges in some features. Maybe it's DC. So I'm sort of arranging that one, and you can change ranges up and down using these buttons. And this is one I didn't see before here. 10N10G. Is that mega ohm and giga ohm? It does say input Z, so yeah, it could be. Like my Fluke A842A, which I had on the bench before doing testing. That's a really high impedance input, and if you have a voltage connected to it and take it away, it still displays it. It just sits there. So I'm thinking this is probably very similar to that function where it doesn't load down the circuitry it's connected to at all. It just sits there. It takes very little, really small sample, and no loading. So that's probably what this part here is good for. So yeah, okay. I didn't notice that before in there. So why did I not notice that before? I wonder. Was it because it's auto range? Ah, that's why. Because I had auto ranging. The option's not available in all ranges, so it's only in these lower ranges, looks of it. So up to 200 volts. So up to 20 volts has got that option. Then it disappears on the DC input, and AC is not there at all. So that's probably why I didn't see it before. I think it's doing anything. No, it doesn't. But obviously just only for navigating these certain menus. So I think I've covered everything now. I think I've done it. These buttons are just they need a bit of wearing in, I think. Let's just try that again. Yeah, that's just a bit better now. This needs wearing in. Right. All that manual delay. I'm not sure what you use that for. Obviously, because of the triggering, of course, it's triggering section. As far as functions go, I mean, this is very broad ranging. Alright, that's the kind of word I'm looking for. It covers a lot of the things you'd want in a multimeter. A lot of things that I would never use are also in here. It's a little bit disappointing about the continuity setting. And why is that buzzer going off? Oh, because I've got this plugged in. Take it out. Right. So, you know, the actual speed of that buzzer and the reaction times for detecting that it's closed, you know, that's just too slow. You know, you need to try and work on that, Siglent. You know, it's if you're trying to quickly do testing through something, or you're looking for an intermittent short or something like that, moving a circuit board around, or an intermittent break, you're trying to flex something, you want it to be really quick. You know, really quick on, really quick off. You know, this has got a delay on and a delay off. Right? So that needs to be faster in both directions, because if you're holding across, say, a broken trace on the circuit board, and you know there's a break in there somewhere, and you're flexing the board a little bit, you want it to stop so you can hear when it's breaking, you know, when it's disconnected, you know, that kind of thing. So anyway, alright, that's, you know, that needs improving. Everything else seems to work fine. Capacitance, I wonder what frequency it measures at. I mean, I don't know, it's interesting. That's interesting. I'm not sure what frequency the what frequency the capacitance runs at. I mean, obviously all capacitor testers run at measure at a certain frequency. I'm sure it's in the manual. I just haven't read it, not all of it anyway. So I don't remember reading anything about what frequency the capacitance measurement is done at, because that frequency must be, you probably don't know this anyway, but the frequency that measures the capacitance at will determine the accuracy of the reading. So bigger capacitors like these things here, I might want like 50 Hertz or, you know, 100 Hertz or 120 Hertz measurement, for example, right? That's what it'd be specified at. But a much smaller capacitor might be 1 kilohertz or 10 kilohertz or 100 kilohertz, depending on what's in the data sheet for that capacitor. But usually that's generally what is. The bigger the capacitor, the higher the frequency, because it's used for RF power supply smoothing, so it's different frequencies that are expected to be exposed to. So what frequencies this measures at, I should actually look into and mention that properly. So I think I'm pretty much done with this now. I've covered a lot. I can't think of anything else I haven't done. I'm pretty sure I've covered everything. Yeah, I think I'm done. English, short languages it's got, shall we? English and Chinese. So this particular one has only got those two languages in it. The SDG3032X, which I reviewed, was it that one, or was it the SDS1202XE? One of them had like 8 languages in it or something. and that was quite impressive. So I don't know, maybe they'll roll it out to other devices as well. Just 2 languages seems a bit limited. I can understand Chinese because that's where it's made, and English because that's probably one of the most spoken languages. But I'm sure there's like Spanish is also quite commonly spoken. So I would have thought there'd be some more major languages in here, and German as well. So yeah, I don't know, but that's just what's in there. So I'm sure that'll be expanded later on once development is required. But maybe because it's mostly numbers, there's not much language required. I don't know. Anyway, so I'm going to call it that. I'm going to call that, and say right, that's enough, and I can start building this review video, which is probably going to be about an hour and a half, maybe longer. I was tempted to split into 2, but no, we'll see how we go. Right, so have a good one. Let me know what you think about the review. This is I believe it's a very new unit, and I haven't shown you the back. I'll show you the back. Let's turn this off. Let's pull this out. I haven't shown you the back of the unit. That's a bit slack of me, isn't it? I didn't even show you an unboxing, but I was tempted to, but I already had the thing out and I was playing with it, so I didn't bother. There we go. So here's the back. Oh, you want to see that, not the ceiling, or up my nose, or whatever you got then. Right, so there's the back of the unit. So we have here a fuse here, 10 amp fuse for the current sensing. External trigger, 5 watt max, VM comp as well as that menu option there. There's a ground point here. LAN USB obviously is the locking port here, so you can lock the thing onto a bench. Voltage selection over here, which I'll move the cable out of the way for you so you can see it. So 100 to 120 and 200 to 240. So surprisingly, it doesn't have an automatic sensing supply in here. That's something that's coming fairly common, but I think that's absolutely fine. I mean, it's probably, in a way, it's probably more robust having this anyway, because the power supplies are better designed for those ranges, and I think it is a bit safer. I've had stuff which is auto switching and the capacitors blow up because they can't handle the voltage that goes into them when it goes to 240 volt from 120 previously. Anyway, so here is an extension card bay with nothing in it. I believe there's nothing in it. Well, nothing came up in the menu, so I don't know what extension cards are actually for this. I'm sure that'll be revealed in time. But so yes, that's the end of that. So remember to give me feedback and let me know what you think about the review, and whether you got to shut my nostrils or not when I dropped the camera just now. I don't know. Anyway, so yeah. So have a good one. Catch you later, and let me know what you think. Bye.